Welcome to Everything Distributed. Today, we are going to talk about cloud computing, one of the most popular form of distributed computing nowadays. And before I go into detail, let me share some observation with you. First, cloud is growing, and then every tech company you know is using it. Netflix, Twitter, Uber, Google, Facebook. So as an end user, you are also using the cloud a lot. And due to COVID, then like the entire industry, no matter what industry you are in, you are kind of forced to adopt the cloud. If you are using Zoom, you use like Skype, like Microsoft Teams, you use tons of email, you use some kind of website to manage your customer or like your product, your goods. Lots cloud because you store something remotely and then you need to manipulate the data or you need to do some computation remotely. And because we are forced to work remotely, and then the market of a cloud actually grows a lot. And then personally, I think that this growth will continue at least in the next few years. So it's important to understand what cloud is. And then if you look at the history, this was a long-held dream by some very visionists. Back in 1965, a faculty at MIT, Fernando, and his colleagues envisioned that our computer doesn't need to be constrained as a single cell laptop or like desktop machine. We can have some computer facility, not just like a utility company. For example, it's like a power company or water company. So what does that mean? A very important feature is the plug and play. You don't need to bring anything. You just need to have an interface. You connect your thin client, it may be a keyboard or it may be a screen, into the computing utility. And then you can run whatever applications that utility that company provides. So here's an illustration. I have a computing utility that's kind of far away remotely. And then I only need to bring my monitor, just connect to it, and then I can play games, I can watch movies. So think about it. The way you use Netflix, the way you play online games is just like this. But there's a very important difference from their view between their view and then the cloud computing nowadays. So in the paper, they envision this kind of computer or computing as a utility. The first part is kind of similar. They say that I have a computing system that runs continuously 724. And because they want to just like be just like telephone or car power up systems. And then if you think about it, nowadays it's just like that. And then more importantly is that they need to be able to handle the ever increasing or dynamic demands. So that part is good. But the way they build the system, at least the way they envision, is a little bit different. They want to have a single powerful computers that provide this kind of service. So the question for you to think about right now is that how do we actually build a cloud? How do we run the cloud nowadays? And then if you don't know what cloud computing is, you want to know more about detail, I highly recommend you to read this tech report by Berkeley. They document their view and the important research resource or research direction in their technical report, even though it's at 2009, but like most points there are still very valid. And then the important thing they kind of identify is that the cloud computing actually refer to both the applications that can be used over the internet and then the whole infrastructure behind it, including the hardware, including the software, firmware that help to run the service. And then the two key points is that it's not just a software as a service. Cloud computing, at least the way we view it, the way we operate it right now, is that it's the whole stack. It can be from hardware on top to the application, to different kinds of software, and then to the service. everything is a cloud computing. Later, we are going to see like more distinction there. Okay. And then remember, why is it related to utility? It's because of the notion of infinite resource. And then in terms of technical terminology, it refers to scalability. Suppose you also only have one small machine that can only handle the workload of one client. And then in the literature, there are two ways to dealing with this limitation, because I want to handle more clients, more workload. And then the one horizontal one, or so-called scaling out, is adopted by the cloud design. And then the other end, we have the vertical one, is I scale it up, meaning that you get in a better or larger computers, and then that's adopted by the high performance computing or supercomputer way. And then illustration wise is that for cloud, you just get more and more computer, even though each of them is not very good, it's just out of the shelf. Once you have enough of them, you can scale, you can serve lots of people, lots of clients. And then HPC is a highly specialized system. You need to kind of beef up your machines. Okay. And of course, this is a very rough comparison. Nowadays, people actually try to bridge the two together, but that's beyond the scope of at least today's talk. And then in terms of research, actually, we came a long way. It has been there are tons of related research area, research topic, ranging from grid computing, cluster computing, of course, like this HPC supercomputer, and finally we have cloud computing. And then people say that cloud actually is not enough to handle everything, the workload we are dealing with. We need to have include a smaller data center, smaller device, or the edge computer, all those things, and that's called like fog computing, mist computing, edge computing. And then I haven't even included the internet research, like fault tolerance area, application, like software engineering, infrastructure. And then there are tons of exciting research and engineering topics in the cloud. And if you're interested, I encourage you to read the reference here. We have like difference between cloud and grid, like fog computing, and what's a micro data center, so on and so forth. And then now, hopefully you roughly have an idea of cloud. But then why do we want to even have this kind of notion? Why do we need to have a cloud? And in terms of user, there are three key benefits. The first one is the economy of scales, is that purchase one machine actually is expensive, but if you can purchase tons of them, then the unit per unit cost actually is lower. And then so for this economy of scale, actually that works for the big cloud provider like Amazon or like Microsoft. But the second benefit is for users. Suppose you want to use the service, then you're using 100 service for 1 hour. Actually, should be identical to use one server for 100 hours. Okay, so that provides tons of flexibility on how much resource you should get. And then the third one is that, so the way we design the machine and the way the hardware and software work is that you are going to encounter tons of bugs and then tons of failures. Then for a single machine, you can just reboot it. But like for 100 machines, for thousands machines, for tens of thousands machines, it's not easy to manage it. And then a those big cloud provider has the expertise to manage and to maintain the machines, the data center for you. So you don't need to, as a user, you don't need to have those expertise. You can just say that provide me the application, provide me the service that I needed. So let's give you a peace of mind. Okay, so that's the three key benefits. And now I want to focus on the second one, the on-demand service. And then we also sometimes refer it to the, say like it's elastic computing. So for most of the application or for most of the service, the demand actually is fluctuating. And even though you suppose you can perfectly predict what the demand is over time. So x-axis is the time, y-axis is the demand. And now suppose you want to buy the machines to serve or to provide to serve all those demands, what can you do? If you always aim for the best, the highest demand, then you are going to over provisioning, you are buying too much machines, and then you are wasting resource in this area, right? Then if you are aiming for kind of something smaller, then you're under provisioning. So suppose that the user is in this area, then their service will certainly be interrupted, be affected because your machine is not big enough. Your machine, you don't have enough machine to serve the demand, and then that's in general not good for your company, not good for your service. And then that's one very big advantage for cloud. You have this on-demand resource, you have this elasticity. So it's just like the way you use water, right? You don't need to decide, say, oh, today I need to use 10 gallons of water. You can just open the faucet and say, oh, here's the water. And then the abstraction for the cloud, at least the notion of cloud we have today, is just like that. And there are tons of public cloud providers. They have Amazon, Azure from Microsoft, like Google Cloud, and then lots of the smaller one. And then many of them actually provide a free tier account. So I encourage you to sign up those and then just get a feeling of what the cloud is. You can get tons of different service there. And there are also 4 interesting features identified by Professor Indy Gupta from UIUC. So here I borrow his points here. So the first one is massive scale. So remember I talked about cloud because we want to have this scalability. We have this horizontal scalability. You have tons of machines, and that's a massive scale. And then on-demand access, we also saw that because of this over-provisioning or under-provisioning issue. So that's good. And also the echo with the notion of utility. And then 2 more feature is that now the limitation is a little bit different. So actually we need to write our code differently in order to have efficient computation or efficient utilization of your cloud. And then because of the way we operate cloud is a little bit, it's actually very different from what we used to. We also need to have a new kind of programming paradigm. And what's data-intensive computing? And in a sense, it's that this very old buzzword is a big data. So what's a big data? Right now, different company or application collect tons of data. Then how do they deal with it? Where do they store it? They store on top of cloud, or more precisely, they store inside of data centers. And now we have the issue of data locality. Because if you always want to move the data around, say move from California to here, to East Coast or to Europe, then that takes time, right? So you don't want to move data around. You want to center around the data, and then that's a computation near the data, so you can utilize data locality to improve the performance. And because we are doing this, actually the CPU most of the time is no longer the bottleneck. So think about it. What would be the bottleneck in this case? And the bottleneck is the I/O. And usually we refer to the access to a disk and the network when you transmit something, when you do communication. And then that's completely different when how we do it in the high performance computers or how we do on a single machine. And then if you remember from the Berkeley kind of point of view of on the cloud, is that it's whole stack thing. It's not just a software. It's like from application and from the middle layer, middleware, and also the underlying like hardware resource. So we are seeing all kind of software as a service or platform as a service or even infrastructure or some of the public cloud provider also let you run a virtual machine or hardware, all kind of thing. So it's very diverse. And because of this, we also need to have a different way of doing our computation, and then we have all kind of a different kind of programming language or programming platform that we can play with. And then in all era we have this MapReduce that's pretty popular, and also we have the Spark doing all kind of batch processing, stream processing, and also we have this programming model from Microsoft that try to answer your question, or like solve certain problem with a huge amount of data inside the data center, or sometimes even across data center. And also like we have a different way of store our system, because that now the data you need to think about a global scale. Then when I do a query, where should I send the query to, who should store the data, and then what's the structure of the data to be stored, what kind of interface can I provide. There are tons of interesting property to look into. And then the way we send a message is also different. If we only send it like by UDP, by TCP, actually it's very, very difficult to maintain and very difficult to keep track of. And we also need certain type of guarantee to make our life as an application developer or as a system kind of operator much easier. So we have a Kafka, we have a RabbitMQ to provide different kind of performance and guarantees. Okay, so today's takeaway is that where's idea for cloud from? It's from this utility computing, utility company. And then we talk about like, why should we care about cloud? What is the benefit? What is the features? And then finally, I also mentioned that in this point of view on like 4 distinct features of cloud. Okay, that's all for today. Thank you.